Hi students, today we are starting a new chapter, work, power and energy, or you can say work, energy and power. Okay, so first of all we start with work. Note down the first point. Work is done by a force, or you can say work is calculated first statement is correct. Work is always done by a force. Okay, note down. Work is always done by a force. Work is always done by a force. For example, suppose this is a body and many forces are acting on this. F1, F2, F3, etc. And the body is displaced in this direction. Then work done by F1 will be different, work done by F2 will be different, and work done by F3 will be different, and there will be a total work done. Okay, so work done by F1, work done by F2, work done by F3, and one is total work. Total work done. Okay, so work is done by a force if two or more than two forces are acting on a body and the body is displaced, then work done by F1 will be different, work done by F2 will be different, work done by F3 will be different, and one is total work. Okay, second point. Depending on the nature of force, we can classify the work done, or you can say there are basically three methods of finding work done. One is work done by a constant force, second is work done by a variable force, and third is work done by area under force and displacement graph. I repeat, there are basically three methods of finding work done. One is work done by a constant force, second work done by a variable force, and third is work done by area under force and displacement graph. Okay, write down. There are three methods of finding the work done. First, work done by a constant force. Second, work done by a variable force. And the third, work done by area under force and displacement graph. Okay, so work is done by a force if two or more than two forces are acting on a body and the body is displaced. Then work done by F1 is different, work done by F2 is different, work done by F3 is different, and there is a total work done by all forces. There are basically three methods of finding the work done. First is work done by a constant force, second is work done by a variable force, and third is work done by area under force and displacement graph. So first of all, we are discussing work done by a constant force. Okay, so note down. work done by a constant force. First of all, let us see what do you mean by constant force. Constant force means force is a vector quantity. Okay, so constant force means direction as well as magnitude of the force are constant. Okay, note down. Force is a vector quantity. Force is a vector quantity. So constant force means direction as well as magnitude of force. Constant force means direction as well as magnitude of force are constant. Let us take some examples. Suppose I say that a 10 Newton force is acting towards east. It is a constant force because magnitude of force is 10 Newton and direction is eastwards. Okay, so note down. First example, a 10 Newton force acting towards east is a constant force. Second example, suppose I write F equal to 2 I cap minus 3 j cap plus 4 k cap Newton. This is also a constant force. Reason being 2 minus 3 and 4. These are constants, and I cap, j cap and k cap are constant unit vectors. Okay, so this force is also a constant force. So first of all, you have to identify a constant force. Okay, now come to the second point. Work done by a constant force. W is dot product of force and displacement. And dot product is always a scalar quantity. Okay, this is vector, but this is scalar. Reason being, dot product of two vectors is always a scalar quantity, or you can say it is Fs cos theta. Where theta is the angle between F vector and S vector. Okay, theta between F vector and S vector. S vector is also written as R final vector minus R initial vector. Okay, so it can also be written as F into F dot R final vector minus R initial vector. R is the position vector. Okay, and what is S cos theta? S cos theta is displacement in the direction of force. And what is F cos theta? F cos theta is component of force in the direction of displacement. Okay, so it can also be written as F into S cos theta means component of S in the direction of F. Or it can be written as S into component of force in the direction of S vector. Okay, component of force vector in the direction of S. Look down this much. So work done by a constant force is given by F dot S or Fs cos theta or F dot R final vector minus R initial vector or F into component of S vector in the direction of F vector or S into component of F vector in the direction of S vector. Right? Now write down the third point. W equal to F dot S means Fs cos theta. Angle between two vectors always lies between 0 degree and 180 degree. Okay, no doubt. Angle between two vectors, comma theta. Angle between two vectors, comma theta, always lies between angle between two vectors, comma theta, always lies between 0 degree and 180 degree. 0 degree and 180 degree. Second point. If theta is acute, then cos theta is positive. So work done will be positive because this and this, these are the magnitudes of a vector which are always positive. Okay. So basically sign of work done will depend on the sign of cos theta. Note down the next point. F and S are magnitudes of two vectors. F and S are magnitudes of two vectors which are always positive. Which are always positive. So sign of work done. So sign of work done will be decided by the sign of cos theta. Will be decided by the sign of cos theta. If theta is acute, cos theta is positive. If theta is acute, cos theta is positive. So work done is positive. If theta is obtuse, cos theta is negative. So work done is negative. If theta is 90 degree, then cos theta is 0. So work done is 0. Okay. So I am writing different work done at different angles. You can note down, make a table. Here you can write theta, here you can write work. If theta is 0 degree, then work done is plus F into S, because cos 0 will be 1. Cos theta, you can write it here, cos theta, it is plus. If theta is 180 degree, then work done is minus of Fs, because cos 180 is minus of 1. If theta is 90 degree, then work done is 0, because cos 90 is 0. If theta is acute, then work done is positive, because cos theta is positive. If theta is obtuse, then work done is negative, as cos theta is negative, and the general formula is W equal to Fs cos theta. Okay, so work done by constant force is given by F dot S. F dot R final vector minus R initial vector, or Fs cos theta, or force into component of displacement in the direction of force, or displacement into component of force vector in the direction of displacement. At 0 degree plus Fs, at 180 degree minus Fs, at 90 degree 0, acute angle positive work done, and obtuse angle negative work. Okay, just note down. Now let us take some examples of work done by constant force. Examples of work done by constant force. First example, a constant force of 5 Newton. Note down, a constant force of 5 Newton is acting at 37 degree. A constant force of 5 Newton is acting at 37 degree from positive x-axis, towards positive y-axis, Please stop. The body is displaced from 2, minus 4, 6 meter to 6, 2, minus 2 meter. find work done by this force. Find work done by this force. Now you see, force is this. This is 5 Newton at 37 degree. Let us find its components along x and y axis. Component along x axis will be 4 Newton, 5 cos 37 degree, and component along y direction will be 3 Newton, 5 sin 37 degree. Okay, so force can be written as 4I cap plus 3j cap, or you can write it like this: 4I cap plus 3j cap plus 0k cap. And what is S vector? S vector is R final vector minus R initial vector. R final is this, R initial is this. So 6 minus 2 means 4I cap. Minus of minus 4 plus 6j cap, and minus 2 minus 6 means minus 8k cap. So this is the displacement. Okay, so displacement vector is R final vector minus R initial vector. Now what is the work done? Work done is dot product of these two vectors, F dot S. And what is done in dot product? Coefficients are multiplied and added. Okay, so it is 16 plus 18 plus 0. Okay, so work done comes out to be plus of 34 joule. Okay, so work done by this force is plus of 34 joule. Now down. Now there is a note point, write it down. Work done comes out to be positive. It means angle between F vector and S vector is acute. Okay, note down. Work done is positive. Work done is positive. So angle between F vector and S vector, angle between F vector and S vector is acute. Angle between F vector and S vector is acute. Okay, now let us take the second example. This is a 2 kg block. A force of 16 Newton is applied on this block. Write down the question. First part, find acceleration of block. Find acceleration